Hello, hello. This is Daniel Warfield from Ragmasters. Today I'm riding solo, and we're going to be talking about something I'm very excited about, which is LangGraph. LangGraph is super freaking cool, and it's actually something I'm pretty passionate about. I kind of invented it, not really, but I made like a simple version of what is LangGraph now about a year ago. It's a really exciting paradigm. It's very cutting edge. It's a very different way to build an agentic system. And today I want to talk about it. So when we think agentic systems, we usually think something like React. It's like this autonomous agent that it's based on a language model, and it can think and do stuff and make observations, whatever. And it usually looks something like this, right? So you give it some task. Maybe it needs to find some information, or maybe it needs to figure something out for you, or I don't know, needs to order your favorite pizza or whatever. And the way it does that is by using tools. So you basically tell the language model, the agent, hey, if you put out this text, I'll do stuff for you. So if you say search Apple Remote, I'll search Google or whatever for Apple Remote. So an agent can use these tools. You can also, think about stuff, right? So this is kind of like a derivative of chain of thought prompting. And then it can make observations based on the tools, right? So with these things together, the React style agent, and a lot of agentic systems that aren't perfectly React, but kind of React derivative, they can kind of they don't just answer a question. It's like you don't give them a question, they just answer it. They think about stuff, they reason, they use tools, they make observations. And after several rounds of this process, then they end up with your result, which is really freaking cool. It's cool that they can do more complicated things than just answer kind of trivial questions, but also in some ways they're not super cool. Basically, the way there's a lot of steps, and it can be kind of complicated, but you can really break down a React agent as basically just telling the language model, you have a bunch of tools, you can think about stuff, have fun, right? And for a lot of problems, things can go great, right? It understands your question. It thinks up a series of steps it should accomplish. Those steps go very nicely. It uses tools, and the tools work out great, and everything's hunky-dory. But sometimes it's a complete catastrophe, right? Sometimes it gets confused about something, or something happens, and then halfway through this convoluted cycle of a language model looking at previous output from itself in this agentic system, it just explodes. And that's a problem, right? We have basically when you build a React agent, you make this one massive prompt that governs all of the processes that an agent has to do to come to a conclusion, which is kind of fragile, right? It's really hard to adjust this massive prompt based on a specific use case. Also, because it's based on this massive prompt and what it did previously, it's really hard to predict what's going to happen within an agent. An agent might do all sorts of crazy stuff. It's really hard to have any idea of what the agent might do. And as a result, it's really hard to test an agent, right? So it makes a really slick Twitter demo, which a lot of companies have used to make a bunch of money, or to raise a bunch of money. But then when you actually build a product out of it, as we all know now, things usually don't go so sweet. So hopefully, well, yeah. So building products isn't always right. If you're doing a simple system, a React agent can be very effective. But sometimes doing proper software development stuff with an agent is kind of a dumpster fire. And that's kind of why, to a large extent, React agents have been relegated to tiny little problems. While the big boy stuff, big heavy lifting processes within a complex system are just done with normal software, predictable software that can be tested, all that jazz. So that's where LangGraph comes in. It's, I don't want to be too hypey. We have yet to see exactly what this build paradigm is capable of. This might be the messiah that turns all computers into AI systems. Maybe we'll get AIOS. Maybe not. Maybe more realistically, it opens up that next frontier of possible products, and we have to figure out where it fits nicely, where it doesn't, and how to build. So I'd like to talk about LangGraph to give you an idea of like how it functions and how it is sort of different from other agentic systems. So instead of just like giving a React style agent just a big thing to do, and then the agent decides, okay, I need to do this sequence of steps, and I'm going to think about this, and oh, this messed up, let me go back and do some other thing. Instead of the agent sort of autonomously deciding what it does, you block out what it does. And obviously this depends on your use case. We'll go over a practical example, but you block out a list of things that you need the agent to do, right? And then you connect them together. So once it does one thing, it does another thing, and then it does another thing. And this is like kind of like your classic Lang chain, which, Lang chain was before LangGraph. But what's cool about graphs is, so graphs, this is a graph, by the way, if you don't know what a graph is. It's not like the, charts over time. We're talking about nodes connected with edges. In math speak, that's a graph. And what's cool about graphs is it doesn't have to be linear, right? So if you tell the agent to do something, then you can like have a check and say like, hey, did it go well? And then if it did go well, you can do one thing. And if it didn't go well, you might do another thing, right? And again, we'll get into like a more specific example. But this is in stark contrast with this just let the agent figure it out mentality. And in some ways, let the agent figure it out might be appropriate. So you might want to use a React style agent. But if you're trying to like put an agent in a predefined system that you already kind of know generally what it has to do, having these extra constraints can be really beneficial and enticing as a software developer for a variety of reasons. So yeah, like this having this structure rather than just saying, off to the races. So let's imagine an example. So imagine you're a real estate agent, right? And, you're having fun, making a bunch of money because the housing market's absolutely insane right now. But, oh my gosh, everyone wants a house. I'm getting calls from this person and that person. They're like, hey, who are you? I need a house right now. And they're all giving you the same information. They all or you need the same information. So they hit you up and you're like, all right, what's your name? What's your budget? You got contact info. You're moving in, whatever. And, different real estate agents have a different process for this, but the general process is called lead qualification. So when someone completely random off the street comes up to you, you need some like basic information so that you can kind of initiate any process, right? So wouldn't it be cool if we could get an AI to do this for us? Someone texts us or gives us a phone call or whatever, and the AI collects this information, and then we can decide which leads based on their budget and maybe some other criteria are worth pursuing, which aren't. Maybe we can catalog and organize them in some way. And then, I don't know, we can do whatever real estate people do when they have time. So we can throw paper in the air with all the new free time we have. So you can kind of think of this as a graph, right? So how would you, as a human being, have this conversation? It wouldn't be like just some random series of, you really have to think through and like, it's already predefined. So you guys say, hey, I heard you're interested in a house. What's your name? And then maybe you go, all right, cool. What's your email? And then, all right, great. What's your budget, right? So this is like a really simple example of a graph. And it's cool, but it doesn't really highlight like the power of graphs. Really what highlights the power of graphs is when things don't go perfectly. So like, what if they give you their name, or what if you ask for their name? So they say, hey, I'm interested in a house. And then you go, oh, all right, cool. What's your name? And they go, do you have anything on like 6th Street or 7th Street or I don't know, in Denver, whatever. And they didn't give you their name, right? So what you can do is you can use an LLM to basically evaluate their response and then say, did they give me a name? And then if they didn't give you a name, maybe you can respond to whatever they said and then re-ask for their name. And then if you did receive their name, you can, continue with the conversation. But, maybe when they give you a name, maybe you need their full name. Maybe you don't just need like, I can't just say, hey, I'm Dan. Maybe you need Daniel Warfield for your records or legal reasons or whatever. So maybe you can have a spot in this chain where you check if it's a full name. And then if it's not a full name, you can be like, hey, can you actually give me your full name? But also sometimes names that are full names, they don't seem like they're full names. So they might have like a a name that seems like it's an abbreviation, but it's not. So we can also ask them to confirm if that is actually their full name. So we could either re-ask them for their name, or we could like, we could be like, or is that actually your full name? And what's cool is if you're using a language model, it can kind of figure some of this stuff out. So you can use a language model to say, does it seem like it's a full name? If it does seem like it's a full name, ask to confirm. If it seems like it's definitely abbreviation, re-ask for their full name. And then, you can continue on this merry way. So like, it's easy to see, like, if you were building an agent that was totally like loosey-goosey, and it was just like, off to the races with whatever prompt it had, these weird idiosyncrasies, these little edge cases would be really hard to design around. Where if you're building an agent and you put it in production and you realize a bunch of people are giving you abbreviations of names and not real names, you can add a node in this graph and then build logic to deal with it. And that makes sort of graph-based agentic systems much more robust to actual real-world production settings, which is really freaking cool. I want to go through like another example to kind of hit it home. So let's say you're asking for their email. Pretty cool. But maybe they should have an account with your website or whatever. So first you can ask, hey, do you have an account? And then they might say, yeah. And then, okay, cool. What's your email for your account? And then if they say no, then maybe you can like, hey, here's some setup information, whatever. And then ask for their account. And what's cool is, like, if a human responds, oh, no, sorry, I don't have an account, like a language model can take that response and then decide, did they say yes or no? So all of these decisions of, to go like yes or no, or how to respond, a lot of the time, it doesn't always have to be, but a lot of the time this is done with a language model. So it's robust to common human conversation, which is really compelling. And then, you can also trigger like non-language model stuff. So once you have asked for an email, maybe you can send them a short code to their email. And then, they respond back with the short code in a textual format. Then you might use a language model to parse out the short code. Like maybe they say, oh yeah, I got the short code. It's 13987. Then you ask a language model, can you extract the short code, which is 13987? And then you might send that up to the server. And then the server might say, that's correct or incorrect. And then if it's incorrect, you might say, oh, that wasn't right. Can I get your email again? And if it is correct, you go on your merry way. So you can also inject like proper software in here with like hard stops, which is really freaking cool, because one of the issues around building language model based stuff is security. So if you have these sort of programmatic points where you go, we're checking if this is the person, then it makes a much more compelling sort of security posture for these types of systems, where React style systems are just kind of doing whatever behind the scenes. So the way this kind of all shakes out under the hood, I think there are a few ways to do this. It seems like most people are using state graphs within the LangGraph ecosystem. So basically you define like an object, it's like a dictionary, and you call it your state. And then you define this graph of processes that end up, happening. And then that state gets passed along through this graph, and then the state pops out at the other end. So the state itself is like kind of the thing within the graph. So the nodes are functions. So you can have a function for, checking if someone's name is correct or not. You can prompt a language model to, provide information, then ask for user feedback, whatever. Basically, a node is any code you can do where you take in a state, you do something, then you modify that state and you output it. So these nodes are like taking in state, modifying state, passing it to the next node, et cetera, et cetera. And the decisions that happen within this sort of graph context are also based on the state. So they're also functions. So when you have to decide, am I doing this or am I doing that? You basically call a function that operates on the state. And that function can include a language model. So you can have a function that basically says, based on the user's previous thing that they said, did they give me a full name? And then the language model might say yes or no. And you have to do this in a structured way. So you might be doing something like pydantic parsing to get the language model to output you JSON so that you can actually parse it and then get the result, whatever. But you can basically use language models within functions to make these decisions for you. So it's a really, really powerful and flexible paradigm, which is why I'm so excited about it. So yeah, like this function, it can, also this is kind of cool. It can be an AI model, but you can also have an agent in one of these nodes. So it's not like LangGraph and React are mutually exclusive. There's actually a tutorial about LangGraph where they use a React agent in one of the nodes. So like you have state, maybe you say get the user's question, and then you might also have contact information and credentials and all this other stuff within the state. But then it goes to a node, and that node might be answer the user's question. And you might have within that node, it's a function, and within that function, you might have a React agent, and then that React agent might have tools. And then what its job isn't to solve everything under the sun. Now this React agent just has to focus on a specific thing that you gave it. And then if the React agent messes up, you can make a decision. So it's a really good way to encapsulate application development around general purpose language modeling stuff and also other software engineering stuff, which is really cool. And then, yeah, like this sort of decision making is also a function. So there's a ton of things you can do within the nodes and within sort of the functions that define the decisions that happen between nodes. It's kind of crazy. So it's not like we're going to have to figure it out. So this is a new way of developing language model stuff. And it's not like easy. It takes a little bit of practice, and it can be fairly complex. One of the quirks is, so you have this state that's sort of passing around these nodes, right? And imagine you have some nodes that have functional components that request user input and maybe generate AI responses, right? So you have some conversational components where maybe you ask the user what you want or what they want or whatever. But then maybe you have some other nodes that aren't conversational. Maybe they're like processing data or calling LLMs for parsing reasons or whatever, right? But then at the tail end, you have another conversational component. And what's interesting is these nodes are separated from each other. They don't directly talk to each other. They just modify the state. So if you have a conversation happening earlier in the graph, maybe someone says their name or something, hey, I'm George, and then you do a bunch of stuff, and then you have a conversation later, the language model won't implicitly know their name because from the language model's perspective, it's a completely separate conversation. So one of the things you have to do in this particular example is within the state, you have the conversation. So anytime the user says something or anytime the AI responds with something, you keep a tally of the present conversation so that the node in the beginning, the node at the end, and any other conversational node in between can kind of call this or use this centralized ledger of the conversation thus far from the user's perspective. So we're getting meta here. This isn't. I don't think this is the agentic system you start learning from, but if you're familiar with developing, React systems and other agentic systems, it's pretty cool. It's pretty cool what you can do. So yeah, that's the slides. Basically, the way React works is really exciting, and the way traditional agents work is really exciting. This idea that an agent can make its own decisions, that it can decide to do stuff, it can think, it can use tools. This is very exciting, and it's inspired a lot of people's imagination for a while. The issue is you can't freaking make products out of it. Like, not easily. It's really a pain to make a product out of this sort of general vague agent. So if you're using a graph, you can implicitly design sort of the flow of how the agent operates. And what's cool about it is that can be as granular or as broad as you want. You can have React agents and nodes, and then think of the graph as like a way to check how your agent's doing, or you can be like really nitty gritty and very specific things are specific nodes, and you have this complex sort of interaction between nodes. You can also have LLMs do a lot of the deciding, or if you just define a function that's more explicit and programmatic, you can use code to decide if this thing happens or that thing happens. So it's this really nice interweaving between classical programming and sort of your agentic language model design type of approach. And it's really exciting. So anyway, thank you so much. My name is Daniel Warfield. This has been Ragmasters. We do guests, by the way. So if you're interested in AI, maybe you have an AI company or you're using AI within your sort of circle, feel free to give us a shout. We love having guests on. I actually particularly really do enjoy having guests on. So please contact us. And otherwise, like, subscribe, all that jazz. Thank you so much. And I will see you guys in the next one.